Okay, we'll be talking about the chapter force. Okay, discussing some basics of forces first. Okay, so what is a force? Force is nothing but how can we define force? It is nothing but according to the law we get F is equals to mass into acceleration. Okay, it is that strength or that we will be discussing about the chapter force. As we know, force there are firstly we come to impulse of a force. What is impulse of a force? It is that amount of force, the force which acts for a shorter period of time. That is when a batsman hits a ball, that the force exerted by the bat on the ball is for a specific short interval of time. So so if we calculate that amount of force, that is called as the impulse of a force. Now the forces, if whatever forces we exert, we use in a day-to-day life, they are of two types. There are real forces and there are pseudo forces. Okay, real forces are the forces which takes place in which we know that they exist, and pseudo forces are the forces which we use in our day-to-day life, but we don't know that such type of forces are used. So types of the real forces, we can say that the revolution of the earth around the sun. Okay, that is because of the gravitational motion. Also the motion between two solid surfaces, because of that motion between two solid surfaces, that gives rise to a force of friction. Okay, also the binding energy of the protons and the neutrons. This type of forces are called real forces. Also pseudo forces, which are the forces which we experience in our day-to-day life. Whereas when we travel from elevator, we feel a jerk in the downward direction, whereas the elevator goes in the upward direction. Okay, also if the bus is moving within some acceleration on a straight road in a forward direction, then the person of mass, suppose there is a person, he'll experience a backward force if the bus stops moving. Okay, basically impulse of a force will start with the term impulse. Okay, impulse means that amount of impulse means the amount of force which acts for a short interval of time. For examples, when a batsman hits a ball, that the force exerted by the bats on the ball is there for a shorter duration of time. That force is called as, we can say, it's as the impulse of a force. Now there are two types of forces, basically real forces and pseudo forces. Real forces are such forces like the gravitational force or the force of friction, or we can say the nuclear force. Then pseudo forces, these are the forces which we come across in our day-to-day life, which we experience in our day-to-day life. Okay, like whenever we travel from an elevator, we get a force in the downward direction, whereas the elevator goes in the upward direction. Similarly, like whenever a bus is moving with some acceleration, and then by that the bus stops, then the person inside the bus gets a jerk in the backward direction, in the forward direction, sorry. So that kind of forces are called pseudo forces. Now gravitation, there are certain types of real forces. Those are gravitational force, electromagnetic force, nuclear force. Then in the nuclear force we have two types of forces: strong nuclear force and the weak nuclear force. Now gravitational force, as we all know, it is the force of gravity, which is that is the there is this the every particle attracts every other particle with a force which is equals to F, which is equals to g m1 m2 upon r square, where g is your gravitational constant. So this force, because of this force, we have the sun moving around the earth moving around the sun, and all the planets moving around the sun. So that is the gravitational force. This is the weakest force of all of the above forces. Okay, this is a long range force, but this is the weakest force. Next we come to the electromagnetic force, that force which binds the charges together. That is, wherever they are like charges or unlike charges, there is a force between them. So the force exerted by both of them, that force is called as the force of attraction or force of repulsion, we can say. That is the electromagnetic force. Next we come to the nuclear force. Nuclear force, in this term we have two nuclear forces: strong nuclear force and the weak nuclear force. In the strong nuclear force we have the forces which we have the force between the protons and the protons, which binds the proton. We have the force between the two protons which binds it together in the nucleus. That is why the nucleus is said to be stable. So basically in the nucleus we have is protons and neutrons. So what kind of force is there which keeps the two protons binded together? So that is the strong nuclear force which keeps them binding together. This is the strongest force of all of the above forces. Okay, next we have the weak nuclear force. It is the weak nuclear force is acts in between any two elementary particles. It is very much, it is this time, this is very much this is very much less powerful than the strong nuclear force. Okay, it is but it is stronger than the gravitational force. So we have the weak nuclear force. This type of force is exerted when we have reactions. Okay, so the, uh, the biggest force, the strongest force of all of them is the gravitational force. Then we come the weakest force of all of them is the gravitational force, and the strongest of all of them is the strong nuclear force. Now we'll be dealing with the law of conservation of momentum. Basically, momentum is nothing but the mass into velocity of that particular body. So we need to whenever we need to find the momentum of a body, we need to multiply the mass of that body multiplied by its velocity. So here I have two bodies, one is A and one is B, having some mass m1 and m2. They are moving with some velocities. Here the velocity of u1 is greater than u2. u1 and u2 are the initial velocities of both the bodies. v1 and v2 are the final velocities of both the bodies. Now both the objects are moving in a straight line. Okay, the velocity of u1 is greater than velocity of u2. So basically what happens is u1 comes here and collides with u2, and after the collision both of them are set back. So what happens in this law of conservation, we'll define a law which states that it defines the momentum of them before collision and momentum after collision. So this is before C, during collision and after collision. Okay, before collision the momentum will be, both of them, the momentum of A will be m1 into u1 and momentum of B will be m2 into u2. So the total momentum before collision will be this. Now total momentum after collision will be m1 into v1 into m2 into v2. So total momentum after collision will be this. Now during collision, this m1 will exert a force F in the positive direction along the in the positive x direction. Okay, this will hit the body B in the positive direction. Okay, but this body B will exert a force in the negative direction, a backward force. It will exert a backward force on A. Okay, as this body is large, this will exert some force on A and it will pull A in the backward direction. Okay, so during that collision, the force exerted by A on the A and B is equals to minus of force exerted by B on A. So that is what happens during collision. So we use the Newton's second law of motion, that is force is equals to mass into acceleration. Now what is acceleration? Acceleration is the change in velocity upon time t. Now that velocity can be your final minus the initial upon time t. Okay, so your equation becomes F equals to m u v minus m v minus u upon t. So that force can be from A to B or from B to A. We'll find both of them. From A to B, the mass becomes m1. From A to B, now this force is exerted by A on B. So we have to deal with the mass of A. We have to deal with the velocity of A, final velocity of A and initial velocity of A. So a mass of A, that is m1, final velocity of A v1 minus initial velocity of A u1 upon time t. Now this is the force exerted by B on A. Now we have to deal with the mass of B, the final initial velocity of B and final velocity of B. So m2 is equals to v2 minus u2 upon t. Now we know the equation FB AB equals to minus of BA. So we put the equation both of them and we substitute the values. We multiply m1 inside and m2 inside this, and what we get, the final answer is m1 upon m1 u1 plus m2 u2 is equals to m1 v1 plus m2 u2. This is your initial momentum, initial velocity, initial masses, in final velocity, final masses of both of them. That is, momentum before collision and momentum after collision both are the same. So that is P1 equals to P2. So that is the law of conservation of momentum. That is, whenever there is a collision, the momentum before collision, momentum after collision are same. Okay. Similarly, after working on the initial velocity and the conservation of linear momentum, we are able to find the formula for finding the velocities of the objects after collision. So we have two objects m1 m2 and we need to find their final velocities after the collision. So for that, what we need from the first equation, m1 m2, m1 minus m2 upon m1 plus m2 into u1 plus 2m2 upon m1 plus m2 into u2. Similarly for v2, we have 2m1 upon m1 plus m2 into u1 plus m2 minus m1 upon m1 plus m2 into u2. So what we basically need is the masses of the two objects into the initial velocities of both the objects. Here also we need the initial velocities of both the objects and the masses of the two objects. We can find that after collision what is going to happen with their velocities, or what their velocities will be. Okay. Now there are two types of equations in which there are two types of collisions, that is elastic and inelastic collisions. Elastic collisions are those collisions in which the kinetic energy, there is no loss of kinetic energy, whereas in inelastic collision there is a loss of kinetic energy. Such kind of type of collisions are like we can say meteor showers are there. Whenever meteor hits the earth, then then after the collision, whatever momentum the meteor has before collision, all that energy is getting, all that kinetic energy is being used up, and that is used in some sort of heat energy, is converted into some sort of heat energy, some sort of sound energy. So the kinetic energy gets used up out there. So here the kinetic energy before collision and after collision are same. Here it is not the case. The kinetic energy is not the same. Okay, but here the momentum before collision and after collision is also same. Here also the momentum before collision and after collision is same. Next we have the moment of force. Moment of force is nothing but the ability to produce a rotational motion. What, suppose we have a body, any unshaped body, we need to rotate this body in a rotational motion. Okay, so the ability of this the ability, that is the force, amount of force required to rotate this body in rotational motion is called as the moment of force. So that is defined as the force multiplied by momentum, by whatever angle we are rotating the body, that is the moment. Now we'll be talking about the couples and the property of couples. Okay, now couples are the two equal and parallel forces acting in the opposite direction at two different points in a given body form a couple. So this is my body, and there are two couples which are acting it to rotate the body in a rotation, to rotate the body. Basically this thing we use in taps. Okay, we apply forces, we apply pressure, that is equal and opposite pressure on both the sides. So this amount of these 2 points is this of a given body, we call them as a couple. So for the couple we have different types. We will be discussing about some of the properties of that couple. A couple produces a rotational motion. Yeah, the motion produced by the couple is rotational. The two forces forming couples, they are equal and they are opposite forces, and hence the total resultant is 0. Then now next is the balance. These two couples are balanced by equal and opposite forces. If anti-clockwise couple is acting on the body to produce turning effect, its effects can be neutralized by applying an clockwise couple. If suppose anti-clockwise couple is acting on a body to produce the turning effect, then its effect can be neutralized by a clockwise couple. Okay. Next, the moment of couple of any point in its place is constant. Suppose the moment of couple, that is any 2 points, the amount of moment of couple, the moment of couple is nothing but it is the ability of the couple to produce purely rotational motion, that is called as the moment of couple. Okay, so that means the ability to produce a rotational motion depends on any 2 points. So that 2 points on any surface on this plane will be it is a constant. So the moment of couple, let's see, we have 2 points here, A and F. We have a center C and we have one point D which is directed in the outward direction. So the moment of couple at point C will be, at this point, will be given by force into the axis along which it acts, that is AC. Okay, here we have AC. The couple will be acting in this direction as well as this direction, so it is AC into BC. So F into AC plus BC, AC plus BC gives you AB, so F cross AB is the answer. Next was at point C. Now we find the moment of couple at point A. Now at this point A, the couple will be along AB and it will be in the backward direction, but we have no other thing in the backward direction. So for the backward direction we get F cross 0, and for the forward direction we get F cross AB. So that is F cross AB, we get answer F cross 0 is 0, so F cross AB. Next, moment of couple at point D. Now at this point we have AD. This certain amount of couple is acting in the backward direction, so it is minus AD and into F cross BD. Now this total distance BD is the moment of couple acting in the forward direction. Okay, so we have BD minus AD, so this BD BD minus AD becomes equals to AB, so that is AB. So F cross AB, F cross AB, F cross AB, that is the moment of coupling. A couple acting at any point is a constant. Next we have the center of mass. Center of mass is nothing but the point at which the whole mass of the body is supposed to be concentrated. That is given by this formula R, which is equals to m1r1 plus m2r2 upon m1 plus m2. Next, that is, it is a specific point on a body, on the whole body, where the entire mass is supposed to be concentrated. That is, suppose we have a scale and we have 0 to 30 centimeters in the scale. The center is 15, so we can balance the scale at 15 centimeter, at exactly at about 15 centimeter in the center. So that is the center of mass of the scale of the object. Center of gravity, that is the point at which the whole weight of the body always acts vertically downwards wherever the may be the position of the object. Okay, that is called as the center of gravity. That means there is a specific point where the whole weight that is m into g, the whole weight of the body acts in the vertical downward direction, whatever may be the position of the object.